right, here's my homework video for second lesson. We're focusing on two locations. It looks like 1 and 0. All right, let's go through the easy one, 0. So if I look at the input x equals 0, I have a function value at 1. And this was a situation where I have a function value and I'm approaching said function value. This is one of my boring situations where everything aligns, okay? So if I look to the left of 0, yeah, I'm obviously very, very close to 1. If I look to the right of 0, I'm right up here getting closer and closer to this y-coordinate 1, which means the limit exists. The limit and the function value agree with each other. Here, not the case. At x equals 1. Well, I have two open circles and I have a closed circle. The closed circle is my function value. At 1, my function value is 1. So same as 2. But if I look to the left of 1, okay, to the left of 1 over here, okay, so here are my x values. I'm on the x-axis, closer and closer to 1. I'm up here on this graph, okay? I'm looking directly above and below to see where I have function values. My function values are directly above in this case. And as I get closer and closer and closer to 1, my function values are up here getting closer and closer to this y-coordinate of 3. But if I'm to the right of 1, my function values are down here. And as I get closer and closer and closer to 1, to the right of 1, my function values are getting closer and closer and closer to where this open circle is located, which is at 0. So the left-hand limit does not equal the right-hand limit. In general, this limit does not exist. 3 situations. I got -1, I got 2, and I got 3. Easy one is at 3. At 3, I got the point, and I'm approaching this point from both locations. 3 is easy. Let's look at -1. Okay. Right at -1, at this point, I got an open circle above it, closed circle below it. The closed circle, that's my function value, that's at -1. To the left of -1, my function values are not down here, they are up here. As I get closer and closer to -1 from the left, my function values up here approaching this location 2. So that left-hand limit is 2. If I'm to the right of -1, right here, to the right, my function values are not above it, my function values are below it. There's my function values, there's my graph. The closer I get to -1 from the right, the closer I get to -1 in terms of my y-coordinates. So closer to -1, my y-coordinates are approaching this closed circle, which is located at -1. Since the left-hand limit and the right-hand limit do not agree with each other, this limit does not exist. Let's look at 2. Right at 2, at this location, I have an open circle and a closed circle. The closed circle is my function value 3. But if I'm just to the left of 2, my function values are on this graph. My function values on this graph are getting closer and closer and closer to the location of this open circle, which is at 1. So 2 from the left, 1. If I look to the right of 2, same deal, getting closer and closer to 1, right of 2, 1, which means the limit in general is 1. Using a calculator, let's find f of 2. We got x to the 4th minus 16 over x squared minus 4. If I plugged in 2, I'm not going to use a calculator right now. 2 to the 4th, 2, 4, 8, 16. And then, so this is me like actually not using a calculator, just to check. F of 2 would be 2 to the 4th minus 16 over 2 squared minus 4. That's 0 over 0. It is undefined. Okay? But if I ask you what is the limit as x approaches 2 of x to the 4th minus 16 over x squared minus 4, and I'm able to use my calculator, this is what I'm going to do. I'm going to start by graphing. Y equals, making sure I use parentheses, x to the 4th minus 16 divided by x squared minus 4. And I graph Okay, if I look at 2, again, it's going to tell me, nope, nothing. But I can plug in any other value besides 2, or negative 2. Can't plug in negative 2. Like 1.9. Okay, I'm at 7.61. Let's look at 1.99. 7.96. Okay, let's look at 1.999. 7.996. If I go one more 9. 2, 3, 4. 7.9996. I'm getting closer and closer to the value 8 from the left side. Let's keep going closer. Let's go that many 9s. I don't even know how many there is. Oh, my calculator gave up. It's like, you're pretty much at 2, and you're pretty much at 8. Now, this isn't true. If I plugged in 2, the y-coordinate doesn't exist. Okay? It's undefined. Just my calculator gave up and rounded. Okay? And I can see here, I'm essentially at 2, 8. So this limit, at least on the left side, is 8. Now, I can probably see by the graph that it's going to be the same on the right side. But let's just double check. 2.01, 2.0001. Yep, close to 8. 2.000001. Very, very close to 8. So yes, from the left and from the right, we're approaching the same value, which is 8. So I do not have a function value, but I do have a limit. I should probably keep this up for the key. All right, sine of x over x, f of 0, let's see. The sine of 0 over 0, okay, that's 0 over 0, undefined. Okay, but what is the limit? See if it exists. Sine x over x. Yeah. All right, looks like this. Again, at 0, 0. If I go just to the right, looks like I'm at 1. Let's kind of work our way there. So let's start with like 0.1. All right, 0.998, 0.01, 0.9999, 0.001. Getting closer and closer to 1. If I do 3 zeros, eventually it gives up and says 1. If I go the opposite direction, so from the left, so negative 0.1, negative 0.01, negative 0.001, I'm getting closer and closer to 1. So this limit exists and equals 1. Cool. Piecewise functions. All right. You don't have to graph a piecewise function, okay? Because we've got to know that with piecewise functions, we got one piece that's eventually going to stop. So we got y equals x. You know, like, do I have to graph this perfectly? I don't. Because, and I'll show you why, but like, just to visually display it, this piece ends up at 1, 1. It's got 0, 0, negative 1, negative 1. 1 minus x greater than 1. So like, if I plugged in, like, it would start, and I would plug in like 1.01 in for this, and I would use this. And it would pretty much start where 1 is when I plug 1 into 1 minus x. So if I plugged 1 into 1 minus x, I get 0. That's telling me I'm going to be approaching 0 for this piece as I get closer and closer to 1. If I plug in, 2, negative 1, negative 2, negative 3. So like, this is what the function looks like. And you could go about graphing this. And you could be like, okay, well, it ends up here, and then, I can't use 1 for this because it's not supposed to, but I can use 2 and 3. Yeah, sure, you can use 2 and 3, but you could also use like 1.5. You can use 1.2, 1.1, 1.01 uses this function. 1.0001 uses this function, 0.00001. Essentially, it's like you're plugging 1 in here. It's like you're finding the function value you're approaching at 1. Plug in 1 to start, and you'd be approaching 0. So you get all these values closer and closer to 0. It would end up like this. I don't need this. Okay? If I'm asked, what is the function value at 1? Well, you use x equals 1. With this piece, I plug 1 into this piece, I get 1. If I went to the left of 1, the left of the 1 is like 0.999. Left of 1 is this. That's x is less than or equal to 1. I'm going to use x, or f of x equals x, that piece. And if I plugged in 1 into that, I get 1. Boom. That's my left-hand limit. If I'm looking just to the right of 1, that's like x is bigger than 1. I'm using this piece. F of x equals 1 minus x. Plug in 1 to that piece, you get 0. That's the right-hand limit. That is why my limit does not exist. If you're looking to the left of 2, well, here's I did this on purpose to try to confuse you. To the left of 2, that's like 1.999. That's still bigger than 1. So I'm going to use the 1 minus x function. Now you might be thinking, okay, so I got to plug 1.999 in here. Well, I can plug 2 in here. And if I plug 2 in here, I get the function value. In this situation, this left-hand limit will equal the function value at 2. And at 2, this piece equals -1. 0 from the right. Yeah, it's like to the right of 0. Well, 0 is less than or equal to 1. So I'm going to use the f of x equals x piece. And yeah, to the right of 0, think about 0.001, sure, but you don't need to because it's just going to be approaching this exact location which has a function value, f of 0, which is 0. Limit as x approaches 3. Well, 3 is bigger than 1, so use this piece that the function is defined for numbers bigger than 1 using 1 minus x. I use 1 minus x. I plug in 3, I get -2. Okay. Let's find the one-sided and general limits at -2, -1, 0, 2, and 3. Okay, so let's start with -2. Well, that's less than -1. I'm going to use the x squared piece. And g of -2 will equal 4. That is what's -4 from the left. That's -4 from the right. I don't have to worry about a one-sided limit being differ. So let's see how I'm going to write this. -2 from the left equals 4. -2 from the right is 4. -2 in general is 4. This is one of those boring situations where the limits and the function values agree. X equals -1. Here we go. Now, this is different because if we are -1 from the left, to the left of -1, x is less than 1, I will use x squared. And using x squared, I get 1. So negative 1 from the left is 1. Negative 1 from the right, I would use the values where x's are just a little bit bigger than negative 1. I'm going to use the 3x plus 4 piece. I don't have to graph this. Just got to figure out which piece is used for which situation. So g of negative 1. Now, I don't have to plug in negative 0.999 because like this will pass through this point here at negative 1. And that'll be negative 3 plus 4, which is 1. So the right-hand limit is also 1, which means for 1 in general, we equal 1. The left-hand and the right-hand limit equal each other. If you were to sketch this out, what would this look like? X squared would stop at negative 1, 1. 3x plus 4 would pick up at negative 1, 1. Have a closed dot. They would meet up. 3x plus 4 would take off in a straight line, whereas x squared is your parabola-looking guy. And since they meet up, the left-hand limit and the right-hand limit are good. So if you want a visual representation, you could do that. Now at 0, well, that's between negative 1 and 2. I'm just going to use, and it's going to be a boring situation, 3x plus 4. And if I know what g of 0 is, which is 4, that's my left, that's my right, and my limit in general. So 0 from the left, 4, 0 from the right, ends up being 4, 0 in general is 4. Let's look at x equals 2. This is another interesting situation where the left and the right-hand limits are going to be different, because if I'm looking just to the left of 2, just to the left of 2, x is just less than 2, I'm going to use 3x plus 4. And g of 2 is 6 plus 4, which is 10. So from the left of 2, I got 10. From the right of 2, well, bigger than 2, I would use this 11 minus x. If I plug 2 into that one, because I'd be approaching it even if I use 2.001, I would get 9. So the right-hand limit is 9, which means the limit in general at 2 does not exist. Left-hand limit does not equal the right-hand. And finally at 3, well, x is bigger than 3. I'm using 11 minus x. And all of the things would follow and would be equal to 8. So 3 from the left, 8. 3 from the right, 8. And 3 in general, 8. Okay? Boring situation. Boring situation. Boring situation. It's, I don't want to call it boring, it's our typical situation. This one is typical. Typical. It's what typically happens with functions. These are the interesting. You don't have to label that. That's just from me to you. If I asked you what these were, you were not allowed to use a calculator. Typically, limits equal function values. Function value is 3. I'd be approaching 3 from the left and the right of 2. The function value is 1. I'd be approaching 1 from the left and the right. The function value is negative 1. That would be my limit as well. These are boring. Got to find the secant of pi over 6. Coming at you randomly. Cosine of pi over 6 is root 3 over 2, so that'd be the flipped 2 over root 3. X approaches pi of e to the x. Oh gosh, this seems really complicated. Well, what's f of pi? E to the pi. How am I going to write my answer? As e to the pi. Okay, don't worry about it. Don't plug it in your calculator. Don't give me a decimal. Just leave it like that. That's correct. Couple quick notation things to heads up for. It's still the same process, f of 4. But in this situation, it's negative and then 4 squared. Order of operations says we're going to square before we worry about the negative. Notice, I'm not saying this is negative 4 squared. I did not have parentheses like that. So this is the opposite of 4 squared. That's 16 or negative 16 after applying that. Whereas here, if I plugged in negative 4, this would be the value negative 4 being squared. Just be careful about that stuff. It pops up randomly in this class. These answers are different. This is positive 16. Okay. If we did not understand these graphical limits, any of these problems, we need to do extra work. This was a short homework, so hopefully we all have done it and understood everything. Thank you.